So here goes. Let's hope this is the first in the 48 volt build story. So final top balance is in progress at the moment. I do that with all of the batteries that I actually construct. So what I do is I connect all of the cells together in parallel. So that's the positives to the positives and the negatives to the negatives. And then what I do is I charge them all the way up to the top so they can't take any more. So they've absorbed as much energy as they possibly can. And then I put them all in parallel to make sure that they're all in balance. So this means that the battery pack will be in balance and you won't need all the active balancers and stuff. And then they should last for a long time without needing to have any more balancing done. So at the moment, I'm just using my charger here. And let's see what that's running at. So I've obviously got it set to 3.65 volts, which is the maximum voltage. And at the moment, it's using its 40 amps across the whole of the 16 cells. So that's using 142 watts at the moment to charge all the batteries up. So what happens now is this will just be left to run until it reaches an absorption of current. So the current drops from 40 amps down to 0.1 amps, and then it will cut off. And that means this whole battery pack here will then be balanced, and then I can start constructing the battery box. So I'm actually going to make my own cables up to connect this battery box to the inverter. Now you can already buy these ready-made up and various prices for obviously the length you want. But these come in the box, and I'm hoping you can see that. These are 50 millimeters squared. So I've got myself a couple of meters of each, so black and red, obviously red for positive, black for negative. And this is this high flex stuff I usually buy in other sizes, but this is the 50 millimeter squared obviously, so it fits into there. I've bought some lugs from a different supplier this time, so I'm going to try those out for this to connect up to the inverter. But it's going to be interesting to see how it's actually going to plug into this and how I can actually use my hammer crimper and connect these cables up here into these connectors with I've not actually done it before, so it'll be interesting to see how that one turns out, and hopefully it works okay. So I thought it worth opening one of these up first to see what I've got to deal with inside. So let's take the bottom piece off there, and it's all got little sort of rubber gaskets here, obviously for making sure it keeps dust and water out, I would imagine. So that's out there. And we've got, there's the bit that I'm going to need to sort out, as in get the cable in and then hit it with the hammer crimper. So it's got a little, it's like a rubber sheath inside. And there's another one obviously for holding the cable in place. So that looks fairly straightforward. This doesn't, I don't think this comes out, does it? No, it doesn't come out. So I'm going to have to see how that fits on the hammer crimper and then give it a good hammer once I've stripped the cable back. I think the other thing I need to do on here as well is, because it's, I don't know whether you're going to be able to see that on camera, but I've got to try and judge how much of this cable I can actually get in there. So it looks deeper than my standard lugs that I use. So I'm going to have to think of a way of just figuring out on how to best measure that, so I get as much of this cable in there as possible before I hit down on the metal to seal it in place and make that cold crimp. So I'm going to find a way of doing that now. Right, sometimes the simplest things are the best things to do. So I'm just going to use one of my screwdrivers and literally just put it in there, see how far it is before it goes in and stops. And then that looks like, I don't know if you can see that, but that looks like about the amount of wire I need in there. So that gives me an idea of how far to strip the cable back on one of these ends. So let's get on with that. Before I start whacking it with the hammer, I'm just making sure that I've got enough of the actual punch there that's in far enough on here so it actually makes a good crimp. So I can't actually move it any further forward because of the actual thread there on this particular thing. So I've tried to move it along as far as possible, and I think, judging by the amount that's in there at the moment and the actual like punch, as I said, it should give me enough in there, so once the cable's in there, to give it a good seal and a good crimp. So let's get outside now and give it a whack. Right, here we go. So I've stripped back the cable, as you can see here, and I've gone back a fair whack on that to make sure obviously it fits in the end here, which again measured using one of my screwdrivers. So I've made it that I've actually put these all on first as well. They're quite tight, which is good, which means they'll give some form of seal to that once it's all screwed up and dealt with. But I've got the sort of rubber sort of grommet on there. I've got the thing that grabs around the cable, and obviously the bit that I screw it onto the end with once I've done that. So now it's the nervous time now of actually getting this in here, making sure that it's in the sort of the crimper correctly, and then whacking it with this. So let's get that lined up now. So again, that's about as good as I can get it within the crimper itself. I hope you can see that. So the punch should be in a good spot there. Let's make sure that's in properly. Now the difficult bit of trying to get this in without actually losing any strands at all or getting them flicked out. So what I might do is just get that in there like so. In actual fact, I'm going to do it the other way around. I'm actually going to put it in first, so I know that I'm not missing any. It's quite tight in there, which is what you'd expect. So hoping you can see that there. It's gone in really nicely. The cable's literally around the edge of where the metal of the lug finishes on the inside. So what I need to do now is balance this, get this back into the crimper. It's trying to push its way out at the moment, which is good job I've got both hands on this. So yeah, I can get that in there in the middle now. So obviously I've only got one shot at this, so I need to make sure it works okay. So let's get that in there like so. Hold up the cable so it's in as tight as possible. I'll get a flat bit of the floor as well. Obviously I don't want things to fall out in there. So again, one shot at this, so let's make sure we get it right. And let's give it a whack. So I hope you can see that there. Bring up a bit closer. Seems to have done the trick. It's moved a little bit more than I would have hoped for, but this will all seal in nicely in that. So looks like a really good tight seal on that one. So again, a little bit too much there, but again, I'm not too worried about that because that's going to be covered up. So let's get this back on here. So it gets all a bit tight now. So let's get that round the ends there. So a bit tricky on this. Again, I'm assuming this is to make a proper seal on it. So as you can see, it's made pretty good seal on that, which I'm really happy with. And now we just screw on this bottom part to finish the whole thing off. And there you have it. First one of those I've ever done. And it looks like it's ready to go. So let's get on with the negative. Rinse and repeat time now for the negative. So I've got it already set up because I don't want to bore you with all that again. So it's in the middle this time, and I've not cut as much back. So I'm hoping that will stay more in there this time. So let's make sure that I've got all the bits on there already as well, so I haven't forgotten those before I started. Let's get a flat piece of garage floor and let's give it a whack. And it's done a similar thing before, but I'm going to give it a bit more of a whack because it feels like it's moved a little bit. So that's done in there now. So again, another really good bond on there. So let's move that up. It's gone in a bit easier this time. Let's move the next one up. And again, if you don't want to go through all this, you can just buy the ready-made cables. But I just wanted to give it a shot, seeing as it's my first outing with these, just to see what happened. It's been a little bit awkward, this one. And that's it, it's all about the twisting action. And then if we put that on there like that. And there we have it, negative done. Time for the other end of the cables now. So I'm trying out some new lugs here from a different supplier. I usually use these. They're a little bit more expensive, but their quality's been brilliant. I've used so many of these now and they do the trick. So trying these out. I'll put the link in the description below if you're interested. And obviously these are for 50mm squared cables, the ones that I'm using, and you've just seen me put the push fit connectors on the end. So the reason I'm putting those on is they're not just put the cable in and tighten them down on this one. As you can see, you've got bolts in there. They poke through here, and then I'll just tighten them down on there to connect, obviously, from wherever that is now. So once it's plugged in the front, it'll plug straight into there for testing mode, so I can test it out. Then I can add DC isolators, any kind of other breakers on there after that point, but I just want to test it out to make sure it works. So let's get the other end of the cable sorted. Okay, cables are stripped nicely now, ready to go to put the lugs on the end. I've already put the heat shrink on there as well, ready to just slide up after I've done the bashing as such. So let's get this on and get these cables complete. All right, in ready to go now. So a little bit easier than the other end. So just check that that's in correctly, and I'm holding it incorrectly. So let's give it a bash. That's one more for luck. And I'm hoping you can see that, a perfect crimp. So that's the negative done. Let's repeat for the positive. And another great crimp. Two battery to inverter cables done. So before I kick off on the installation build, which I'm actually quite excited about, just wanted to cover off a couple of important things. Now, first off, when this is fully loaded, it'll be around 115 kilograms, which is actually quite a lot of weight. So hence the reason why I'm actually installing or doing the build while it's on the dolly, so that I've not got any lifting and shifting to do on my own. So no chance of back problems on that front. So that's what I'm going to do for that. And also the other important thing to remember is eye protection, because working on a live battery such as this, and quite a big one at that, you just need to make sure that your eyes are protected. So what I'm going to do now is, while the batteries are currently having their final top balance, they're just doing their final absorption, I'm going to get this unpacked, ready to start number one, as in the first setup and actually getting the cells mounted in the box. But before I do that, I need to obviously remove the front and all the other bits and pieces as laid out in the instructions. And so far the instructions, I've read them through a couple of times and they're actually really good. So fingers crossed for a really good build. So before I stick down these board pieces, I'm just going to make sure that they fit in the right way, as shown on the diagram. So the thinner pieces go on the bottom, obviously, because they wouldn't fit, the larger pieces wouldn't fit. So obviously once I'm happy that I've got these the right way round, I'll go to stick them down. Let's use one of these just to keep it upright. There we go. And I've got a spare piece for the end once I get round to that. Another one there. And there's another one there. Let's keep that in the middle, stop them falling down. And 2 pieces left over to do at the other end. So that looks good, so I'm going to stick them down now. Right, time to get these fully charged and fully balanced cells into the box now. So the configuration on how the cell sits is really important. So I'm just going to put up on screen what the manufacturer's instructions say. And then obviously I need to make sure that I've got the foam padding, which I'm going to stick onto the individual cells, is in the right place as well, also determining which way round the plus and the minus are. So this is the important bit to get right and match exactly what is shown in the diagram. So I'm going to start loading these up. I won't bore you with sticking all of these on, that's going to take a little while. But let's get these batteries in the box. Right, cells have all had the foam pad applied now. And a little tip with these things, they're super sticky once you've taken this backing sheet off. If you do get it a bit wonky, it's not straight, do not try and remove it because usually it'll just break apart. The first one I did, I lost a few bits off from it. I don't know if you can see, but I split it on the end. So the other thing to do as well is don't put too much pressure on it because you see I've dented this. Just run the back of your hands down like that once you've got it fairly square. But yes, I don't recommend trying to take that off and starting again because it can get messy, and these, like I say, are super sticky on the back, which I suppose that's what they're designed to do. So what I'm going to do now is I'm just going to get all of the cells loaded in and double checked that I've got them in the right configuration matching the diagram. So let's go. So all loaded, so what I'm going to do now is just double check the diagram matches exactly what I've got in the box. Right, all double checked now and exactly where they should be according to the diagram, so all the positives and negatives are exactly where they are, right round to where they connect up as the main battery positive and negative terminals there. So I'm going to put on the end pieces now, and then I can get the faceplate in and get them nicely compressed in place, ready to go. Right, time to connect the faceplate now. So I'm using the screws that come in here, or the bolts if you like, and this is marked up as 22 and again referenced in the installation instructions. So all in, I can't tighten these any further because they're metal on metal. So I'd say they're all in, compressed and ready for the next stage. Now the cells are all in and all ready to be connected up. It's time to move on to the second packet, which has got the, if you like, the battery link on it. So that's to get all the bits and pieces hooked up. I'm not going to be using the aluminium bus bars that came with it. I'm actually going to be using the, I think they're tin plated copper ones that came with the cells themselves. So these all came with these cells in the 4 boxes of 4 that I received as well. So I'm going to use those instead of those because I just prefer them to sort of aluminium because of their general properties of current carrying, and they can handle heat a bit better as well, as in when the battery gets warm or is under load. So let's get this unwrapped and start the connection of the battery cells. So these are the bolts and, well, they're called gaskets, but these are the washers that need to be used for the next stage. I'm also going to use the bolts that actually come with the batteries, along with these that I'm going to use, which came obviously in the battery cell boxes. So I'm going to use those with the nuts that come directly with those as well. I don't think there's much difference in it, but I can keep these to one side and spare for other projects as well. So let's get on and connect the bus bars up now. Almost forgot to mention that it also comes with a 10mm socket to actually tighten the bolts down. That came in the nuts bag, so very useful and included in the kit. So next up is to get the crossbars done now. So I need to apply the foam to the back, like so, and then use these screws, or little mini bolts, to actually bolt them down to the main frame area. So let's get that set up and get it done. So foam's been applied. Again, this stuff's not the easiest to get in a straight line. But yeah, I had a good job. Not too bad actually, quite pleased with that. Seems to be easier than trying to put it on the cells itself. So let's get this hooked up now and get these crossbars in place. Let's get these mounted now. And I had a bit of a dilemma because I didn't know which way round to do this, because they've both got similar connectors on the bottom. But what I found is if you look closely, you might not be able to see that, but there's a reference on there, DK-A. Now, I couldn't find any direct reference to what way round they went, but if you look carefully on the installation diagram, you can actually see the difference. So the A goes this side, so if you're looking down as you are at the moment, and then the B goes this side. But again, that was something that threw me a little bit, because obviously I wanted to make sure that I didn't set it up incorrectly. Obviously you've got the positive bits is where these go off to measure the sort of voltage and everything on the cells themselves. So you could have probably worked it out, but I wanted to make sure I got these the right way round. So just a little tip, it's DK-A for this side, again according to the diagram in the installation instructions, and it's DK-B on that side. So let's get these mounted. Right, it's the important bit now of bringing it all together. So connecting all of the effectively balanced leads and sensor leads on, and also these as well, which I believe are temperature sensors as well. This is another one where you've got to follow the diagram exactly. And the other thing you can do as well is, if you've got a similar setup, is on the circuit board, there are actually the positive and negatives already marked up. So it's easy to see on here on these particular cells that minuses are easy to see and positives are. So just connecting up, and again, you've got to match the diagram in the installation instructions. So what I'm going to do is I'm going to connect these all together, and I'm just going to finger tight them for the moment, and then I'm going to torque them down afterwards. Now, trying to find torque figures for these particular cells has been quite difficult, but what I've seemed to have found is that as long as it's 6 Newton meters or under, then you're in good shape. So I've got a torque wrench that I'm going to use once I've got all of these down and ready to be torqued up. And then I'm going to do them to 4 Newton meters and see how I get on. Because again, this isn't the end of this. If anything needs to be tightened or looked at a later date, which is the advantage of these particular batteries, they're fully serviceable, so I can whip the lid off and I can re-tighten any of the terminals in there without any problems at all. So let's get on with it. So I'm not going to be connecting the main negative of the terminal as it is yet, because obviously the BMS needs to go in later part of the build. So let's get on with this side. So there's the positive that I don't need to connect up just yet until I get the BMS sorted. But one point of note on this, I did actually drop a bolt down inside the box. So I've got myself a little challenge on how to get that out. But just as a word of note on that, just make sure that when you're doing this, and if you're doing it however you're going to do that for tightening up the bolts, just be prepared that it might slip out of your fingers like it did on mine. So connected up, going to torque that up now. So I managed to retrieve the bolt by taking off the side handle. So that allows you to access, there's a little cavity in here that you can get into. So I actually managed to get the bolt back, obviously with a bit of screwdriver help and that, but be careful if you do have to do that because it's quite sharp. The metal is quite sharp inside. But yeah, I'll take that as a success. So another little tip or suggestion that I've got is when you go to tighten these up, so I'm just getting ready to torque these down properly, is obviously where they are on the top, they tend to move. So look, that one's moving around now. So you just need to be careful that when you're doing the final tightening, that you don't pull any of these leads out when you're getting it down to the right torque level that you're after. So you've got to almost like add some in. So I had to undo a few of these and move this all the way round so that as it's coming round, it's not going to rip it out of the actual circuit board. But there's a little tip. Right, they're all torqued down to 4 Newton meters. And if you do know what these should be torqued down to, please give me a shout in the comments. But if I need to go back, then obviously I can just tighten them a little bit more. But yeah, I'm leaving them at 4 Newton meters at the moment and see how we get on with that. So that's all connected up, and I'm just going to test to see what voltage we're getting out of the whole battery. Right, let's see what we've got at the voltage stakes now. And 58.4 volts. Right, so moving on to the next stage now. I've got a bag marked up as 3, but it's got all the bits and pieces in to make the front plate up. I'm currently on the battery itself, but I've put the lid back on to give us a solid base, and obviously using this to stop anything getting damaged because there's a few bits that stick out on the back. So let's get constructing. So fast forward 1 week and I've got another faceplate. So you don't really know how well you're going to get on with a manufacturer or supplier or what their promises are, but I've got to say Daisy at Duke and Power really came up trumps on this. So she sent out another faceplate and was aware of the problem that I was trying to get sorted with the terminals, which I'll show you shortly, and I'll save you from all the brute force that I did try and apply. And I've obviously stripped screws out, and I've also caused a bit of damage on the original faceplate, which is what this particular one is I'm showing you now. But on the new one, you can see the sort of holes are slightly different size. So yeah, that's a good comparison there. So you can see that the holes are a different size, and I think the screw placement's slightly different as well. So I was never ever going to get any of these terminals actually in this original faceplate. So it looks like they revised the design, which again, I've got to commend them on. You don't really know how a supplier is going to work, or again, if they're full of promises or not, and actually deliver on them. But yeah, she kindly UPS'd this particular one over, which I received within a week, which is pretty good. So I can actually complete the build, because unfortunately this was actually a build stopper, so I did actually have to stop the build, because there was no good trying to put these and force these in and actually damage the terminal pieces here, so that I could actually use them on this revised faceplate. So yeah, thumbs up from actually dealing with, and the after sort of sales service that I got from Duke and Power, and Daisy in particular. So that gives me a bit of hope, and actually, because I want to actually order some more of these in to see how well they stack together and run in parallel. But again, I think that is a thumbs up in terms of customer service. So the other thing that Daisy also sent out were some more screws as well, obviously, because I pretty much ruined most of them trying to get it in the old faceplate. So now I've got these, let's get on with it. Right, so before we start the next bit, I just need to take these nuts and bolts off, because they're not needed until I go ahead and connect up the BMS, which will sit there. I've got some extra screws there as well to actually bolt the fuse holder down there. You get a 13mm socket there as well, which I can use with my torque wrench, and just going to use the screwdriver. So let's get this mounted and then get prepared to put the BMS on. BMS time now, so let's see what we get in the box. Okay, so we've got what looks like the display in there. We have the leads, which looks like we've got a display lead in there and a couple of BMS leads. We've got some screws there, I would imagine, to connect to the BMS, so put the bus bars and the connectors onto the BMS itself. And there we have the BMS. That's ready to mount onto the main board. And I've got another pack of screws. So these screws, there's one's marked up as 20, and I think the other ones are down as 28. So they're to be used to bolt everything down. So, oh, there's the thermal pad there as well to connect this to the main, if you like, face plate. So that's obviously to distribute heat and get rid of heat from the BMS itself. So let's get all these out of there and start assembling. So time to put the display in now. You can only really fit it in one way round so that all of the little buttons come through the front. So it only goes in that way round like so. So obviously you've got to be careful because the board is quite near where the screws go in. So I'm using the screws marked up as 28 for this. So the buttons have come through perfectly. So that's the display mounted. Time to use the thermal pad now. So I want to try and line it up best I can so that obviously it covers as much of the heatsink on the BMS as possible. So I want to try and get it as close to where it needs to be. So I'm going to try and figure out a way of just gently marking the back here so that I've got an idea, at least on two edges, so perhaps this edge and that edge there, exactly where this needs to sit, because it's perfectly sort of rectangle shape to actually match over exactly what you need to cover off on the heatsink itself. So I'm going to try and match out exactly where that needs to be now. So obviously the contact is maximised so that the cooling efficiency obviously is going to cool to the main face plate, so that that's actually set up as best as possible. So I'm going to try and come up with something now. So I've used a good old-fashioned pencil, as you can see, and I'm going to use that edge there, which seems to be the best. So that should, as long as this doesn't stretch too much when I take off the layers. So that looks pretty good there. So I've got another line under I did under here in pencil as well, and that looks fairly level now. So I'm going to peel this off now and then obviously lay the BMS on here and then secure it with the 6 screws that I'm going to be using. Right, moving over to bag 5 now, which has got all of the sort of bus bars or flexible bus bars there, connectors, whatever you want to call them, to obviously connect all of this up now so that we've got the BMS connected to the terminals and obviously going through the fuse, which is also in this bag somewhere. There it is. So time to hook this up and play a little bit of bus bar Jenga. So there we have it, DK1 connecting to the terminal of the fuse and then coming out of the fuse to DK2. DK3 is connected to the negative terminals on the front, and then DK4 is ready to connect to the main part of the negative on the battery, and then DK5 is ready to connect to the positive. So there we have it, all set up. So one thing I've noticed after checking round on here and just making sure everything's in okay, I've noticed that the RS485 or number 1 port's not gone in properly on the BMS, so it's actually holding it back. I don't know if you can see that on screen, but it's actually not in flush, so it's put a bit of pressure on the board. So I'm going to have to try and move that over a bit now, but be really careful because of the fact that I might have to disconnect it slightly and try and realign it now, but that's one that might be worth keeping your eye on when you come to actually mount this, if you're going to mount and build one of these. So it was a fairly simple fix. Obviously I've got to put the screws back in, but I took these 2 screws out here and then I just realigned it. So now it's now flush to the edge of the face plate there. So once I've screwed them back in, all of these should be coming out properly now without actually touching any of the faceplate case. So there you have it. I hope you can see that. That's now flush, and the ports there are actually in okay now. And I've obviously put the screws back in and tightened them down and make sure the others are just tight as well. The ones I can get to anyway, obviously because I've got the bus bars in place now, and I'm not taking all of those out again. But yeah, they're in perfectly fine now. So these ports are now flush with the edge of the faceplate. So another little thing sorted out and fixed. Cabling time now, so we're almost there. Just going to connect up the BMS to the display now, and that's one of the cables here. These are the sense lead and balance lead, and I believe they're also the temperature sensor ones which connect to the little circuit boards on the main one. So let's just connect up the display. So that clips in there. I'm going to feed that actually under here somehow. There we go. And then that should, in theory, just clip straight into there. It's difficult to show on camera, but it's clicked in place. That's clicked in place. And I'm hoping you can see that where I've done that. It's gone under the bus bar and it's there ready to work on the display. So time to connect up the BMS and sensor leads, as in the temperature sensor leads. So this one's fairly easy. You've just got to get the clip, I think, round this way so that you can click that in there like so. And obviously make sure that you've got that in fairly square so that it doesn't bend any of the pins over. Because I've done that before and that's highly frustrating. Right, so the black one's in there. So this is a short one, which I'm assuming will connect to, I think it's the A board. And then let's find here again, we've got to find the one that's got the clip on for the BMS. So there's the clip one there, and the other one should match that for plugging into the circuit boards that run over the battery cells. So let's plug that in there like so. Again, making sure I had a nice click there. So they are all in, ready to connect up. So one thing I've just remembered that I've forgotten to do is actually just put the sort of protection cover over the fuse. So let's see if we can get that in there. And this is a bit of a tight fit, to be fair, because I think this is for cables in here, not necessarily flat kind of bus bar shapes on here. So this might be a bit challenging. Maybe one of those improvements that I can feed back, if not already, to Daisy at Duken. But yeah, that's not going to fit too well, I don't think. It's kind of in place, but yeah, I think it's because they're too wide on each end, so I'm not going to mess around with that too much. It's kind of jammed in place at the moment, but that's probably not ideal. So I'll feed back to Daisy on that one and see what we can come up with in future if they've already got that in the next build, because I believe there's a revised build for this already out, which I'm hoping to get hold of soon. Here are the contents of bag number 6. So we've got all of the screws to actually secure the lid and also the faceplate to the front. We've got the little sticker there that goes over the display, so I want to make sure I get that lined up. My OCD will kick in otherwise. And we've got the little buttons as well to stick on the buttons of the display there, and protection covers for the terminals so that when they're not in use I can just put one of those on there. So let's get the screws out and get the front on. Right, time for the trickiest part, I think, of this now. And that's trying to get all of these cables in here without pinching anything, and then getting it so that it's actually fit in properly. So let's try and get that in there and also hold it in place as well. This might be, if you've got another pair of hands handy when you're assembling something like this, it might be a handy time to get them involved, because it's a little bit on the tricky side. So again, you want to make sure you don't short anything on the battery side of things. So I'm just holding on that behind here onto the terminal part, and that gives me enough purchase on the front to actually drop the screw. Right, let's see if I can get that in there. Because as long as I get some along in the top, then it should be okay. Yeah, I'm holding the back of the terminal connection here because that's give me a good thing to hold on to. So I've got a couple in there now. So before I attach any more, I'm just going to check on the cables that I've got none of them pinched and that I can actually get hold of them. So I'm mainly talking about the connections to the circuit boards along the top. So let's pull those out. I'm obviously not connecting them yet until I've got the front connected up. Right, time to connect up the main negative and positive of the battery. So I'm going to do pretty much what I did for all the other bus bars on here, which have already been tightened down. So I'm going to stick a washer on now and finger tight this. I'm going to put it this way because as I adjust it, it's going to flip itself round anyway. So let's get that on there like so. So yes, I had to cut off the video because I was a little bit upset when the bolt dropped down there. It's taken me a few minutes, I say a number of minutes, to try and find a way of getting it out because it's slightly wider, so I don't know how it made it down there in the first place. So what I'm going to do now is have another go and try and get it on this time without letting go of it. There we go. Oh, thank goodness for that. Final step now, it's time to connect up the BMS and hope all works before pushing the reset button on the front to see if it wakes up, and I have a 48 volt 15 kilowatt hour battery available. So it says to do the short wire first, so you can see on here that there are like little bits that stick out, so you can only get it in one way round really, so as long as these fit into here, so I hope that's visible on camera. So I'm going to plug those in there like that now. There we have it, so they clicked in place, so they're ready and good to go. And I fed the other wire all the way underneath, so it's not interfering with any of these. And then again, just making sure these little sort of, I don't know, bits that stick out go in here. So let's put those in there. This is the longer wire. Let's plug that one in there. And that's one click. And that's both clicked in place. So now I'm just going to put the lid on just to cover it. I'm not going to screw the lid down just yet because I want to make sure that there aren't any problems before I start. Well, if I need to pull the lid off again to have a look inside to see what might be the problem. Right, nervous excitement now. It's time to push the reset button on the front and see if we have ourselves a live battery. Here we go. I'll give you a drum roll, but it's alive. Okay, battery management. Push a button. Okay, its state of charge is at 50%. I guess that's the standard to begin with, but it was fully charged and fully balanced before I set it up. So it looks like we have a battery. I'm just going to get a multimeter now and just check the terminals have actually got the voltage at the terminals as well. And there we have it, 57.1 volts. And since it's had a bit of time, it's actually come back. See if we can get that in focus for you. It's actually adjusted its state of charge. So it's actually saying now 98%. And again, a similar voltage what was being read by my multimeter. So 56.93 volts. So we have a battery, finally done it. So buttons attached, and obviously this has been stuck down. I've got it as straight as I possibly can on this. And the very nice bit now. So I'm going to use the two outside terminals here to connect up to the inverter. So I've got these rubber bungs here, so I'm just going to put one on there first. I think you're supposed to get the bottom on first and then it should slide on. There we go. That's one. I just got to find a negative one. There we go, there's another one. And get the bottom part on first. Slide that one in, then it should go in nicely. So it comes with a bag marked up as 7. So these are like the catches and so forth that you can actually do if you want to stack more of these together. So this this little catch here would mount on there, and then the other hook piece, let's get that out. So the other hook piece there would go on the other battery. So it can obviously, I think it'd probably go that way. Yeah, because if this was being stacked, that would probably be that way round. So it could be locked together because that's where the little feet would go in. So I'm actually going to get another one sorted as well at some point in the near future, so I can see how this works in parallel. And obviously for the parallel connections, I'd use the other two that I've got on the front here. So I'll be running the inverter from these two here at the moment, and then I'll be using these. I think the ultimate plan for this is to try it off grid first, but I actually want to see if I can use this on grid. So there's a whole load of things that I'll probably need to go through on that. But in terms of build quality, very impressed. Cells from Dukan, again, very impressed. I need to actually update the capacity on this as well, because I think at the moment, if we have a quick look through, oh, it's come up saying 100% now. So it's obviously sorting itself out in the background. But I think there's an option on here where you define the capacity, because this is easily a 300 amp hour battery with the cells that I got from Dukan. So it's saying it's 280, but I'm wondering whether that can actually be changed or not. So I can hook up the Bluetooth as well. I believe this comes with Bluetooth. I can show you that once I've connected up the inverter. But at the moment, it's saying it's on 280 amp hours. So I don't know whether that teaches itself as it's used or whatever. If you do know how that works, or similar for the other one, I think it's the Seplos. If you just put that in the comments below just to give me an idea. But next up, to test it quickly with the inverter. The inverter's opened up now, ready to go. So I just need to undo both of those bolts there and then bolt in the cables that I made up. I'm not actually going to connect anything up to this. I just want to see that it fires the inverter up so that I know the inverter's working. And then I'll cover how that's working with the battery in a later video, because I want to make sure that I've got enough solar to actually test it, which has not been very good in the UK at the moment. So it's just to see how I get on with this particular inverter. And again, if it's as good as the 24 volt version of this, which is still running a treat on my shopping cart battery, we'll be in good shape. So I'm just going to connect the cables up now. Always remember, don't connect your battery cables first, because if I was to connect these up now and then put them in the inverter, the two ends would be live. So always connect up the inverter first, if you're, obviously depends on whatever your setup is, but always connect them in there first. Otherwise you're going to be walking around with the ends and they'll both be live because they'll be attached to the battery. So always connect the battery piece last once it's already in there. So let's get these hooked in now and just check the inverter switch is on. Bolted in now, I'll put them through and they're pretty big cables. They're 50mm square cables, so they bolted down nicely. So time to plug one in. So I'm going to start off with the negative. So this should, in theory, bearing in mind this is one of these clip connectors, which I've not really used before. Let's get that out of the way. These are quite big cables as well. Obviously I'm going to try and get isolators involved and all that at a later date. So let's just push that in. And that's clipped in place. That is not coming out. Unless I push, there's a little button on the side. I hope you can see that. So before I clip this straight on, I'm going to see if I can use my my resistor trick to stop the surge going into the inverter, because obviously it's going to have quite a big surge coming from this. So I've got to figure out a way of putting that in there, and then so that it can touch the other bit. So I might have to put the camera down for this bit and fill you in once I've pushed it in. So it did work. It was quite difficult to get it in there, but it's in. It's now clipped on. That's not moving anywhere unless I push the button on there. So they're both clipped on now, and I've just put the cover back over for, well, just to make sure that I don't touch anything. So let's come out a bit on that, and the on button should be around here somewhere. There it is. Right, let's switch it on. And there we have it. The inverter is alive. Let's have a look down. Okay, so we've got the battery voltage, as you can see, in 230 volts. So it works with this battery. Excellent. And the other thing that I've just noticed when I was looking back, the capacity lights have actually come on now. So it looks like it's had sufficient time to learn its state of charge. Again, it's not quite right at the moment, and it's shown just a slight amount of drop, and it's on cycle 1. So I'll take that as a win. So the road to 48 volt has begun, finally. If you do have any comments, questions or suggestions, please pop them in the section below, and I'll get back to you as soon as I can. Thanks for watching, and stay tuned to DaVinci.